Now we'll look at optimizing things like areas and volumes, and to do this we will be using stationary points. So I think I'll just honestly crack into an example. Say I had sort of this kind of shape, and so it's a square. This is 24 cm, this is 15 cm, and each of these things are areas of x squared. And basically they get folded up into something like a box kind of thing, like this. Now let's try and figure out what the volume will be. Obviously this height will be x. Yes, so when we fold this up, we're just trying to get, honestly, this bit multiplied, this area multiplied the height, which is just x. So it's just that ax. And now this is 15 minus 2x, and it's multiplied by 24 minus 2x. So then if we just expand this, so I'll leave that x out, we'll get 4x squared, and then we'll get 78x, because 24 plus 15 is 39 times 2 is 78, and then we'll get 360. So then our volume will become 4x cubed minus 78x squared plus 360x. And now we're trying to figure out the stationary value of v, and the value and whether it's maximum or minimum. So we differentiate dv with respect to x. So we differentiate v with respect to x, so it's dv dx. 12x squared minus 156x plus 360. And then we want to figure out when this equals 0. I'd divide everything by 12. And instantly we can factorize this. And x cannot be 15, because 15 minus 2 times 15 equals negative 15, and that is impossible because we're dealing with errors. And by the way, when you're doing practical problems with shapes and stuff and measurements, you can't have negative. So I'd say reject 15, and x equals 2. And let's see, the volume of that would be 4 times 2 cubed minus 78 times 2 squared plus 360 times 2. What is that? 8 times 4, which is 32, minus 78 times 4, which is 280, 312 minus 312, I think. No, hang on. 280 plus 32. Yeah, hang on. 4 times 70 is 280, plus 8 times 4 is 32, so yeah, minus 312, plus 720, and that would equal minus 280 plus 720, which is equal to 440 cm cubed. Then I'd do d squared v over dx squared for double derivative. That's 24x minus 156. Then I'd sub in 2. And I mean, again, it's not entirely important, the evaluation part of this. We can already tell that this is less than 0, therefore it's a maximum volume of 440 centimeters cubed. Sometimes you may be given multiple variables, but they might give you something like a perimeter, an area, a volume, or a surface area. And then you have to use that volume and the geometric formula, the mensuration formula, and rearrange it to get that thing, to get something like the R or the H in terms of the other thing. And then you do substitution for that, if that makes sense. Like, for example, if it gave you this, 2R and H, but it gave you perimeter equals 5, what you could do is you'd do pi r for that semicircle plus 2H plus 2R equals 5. Then you would go 2H equals 5 minus 2 plus pi r, and then H is 5 minus 2 plus pi r over 2. And then you'd substitute that into, say, an area formula, which would be 2RH plus pi r squared over 2, and you would put this in here. And then you would do all the calculus and stuff.